In this new section, we're going to talk about how to take the derivative of trig functions. There are some boring, dry rules you can learn, added to the other 100 rules you learned, or we can just do these problems using rules we already know. If you want to find the derivative of y equals sine inverse of 3x, well, whenever you change those two arguments, either you introduce an inverse or you take away an inverse. In other words, if you had y equals sine 3x, if you wanted to interchange these two arguments, that's okay, but you better put an inverse there. In our case, on top, the inverse symbol was there, so we get rid of it. We undo the inverse. We say that 3x is sine y. And that's not a very hard step. It just shows that you know what an inverse is, and you really should know what an inverse is. Now we take the derivative of both sides. The derivative of 3x is 3. The derivative of sine of any angle is cosine of that angle times the derivative of the angle. The derivative of y has always been y prime. Divide both sides. Now solve for y prime. Divide both sides by cosine y. And you have y is 3 over cos y prime is 3 over cosine y. Thing is, you really shouldn't have y's in your answer. Of course, if you wanted to be slick, you can put that in for y. You can say it's 3 over cosine of sine inverse is 3x. Your teacher really couldn't mark that wrong. But let's get the answer your teacher wants. So now somehow we have to get rid of cosine of y. Well, I know what the sine of y is, and this is going to generate a triangle. Here is a triangle, and here is the angle y. You take sine of angles, and the sine of the angle is 3x over 1. It's opposite over hypotenuse. And this is going to be the square root of that squared minus that squared. 3 squared, x squared. Now, what's the cosine of y? That's not bad at this point. Cosine of y is adjacent over hypotenuse. It's the square root of 1 minus x squared. That's the adjacent divided by the opposite. Dividing by 1, don't bother. The cosine of y is just that. So we are done. 3 over the cosine of y. The square root of 1 minus 9x squared is y prime. The triangle we drew helped a lot. We get rid of the inverse. We take the derivative of both sides. And then we get rid of y using a triangle. For example, if you had y is equal to, well, let's do cosine this time. Y is equal to the cosine inverse of the square root of x. Well, you can interchange those two anytime you want. It's just the way it is. And if this has an inverse, then this won't have an inverse. If this one up here didn't have an inverse, then there would be an inverse there. The square root of x is x to the half. And the derivative is, well, you bring down the power, you make the new power 1 less. Bring down the half, take away 1. Since this is a negative exponent and it's in the numerator, I'll put it in the denominator. and x to the half is square root of x. So the derivative of that is 1 over 2 square root of x. This comes up, taking the derivative of square root of x comes up so frequently that you should just memorize it. You should be able to do it on your own. But who wants to do all our work? It's just 1 over 2 square root of x. Equals the cosine of an angle. The derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle. The derivative of y is y prime. Okay, so now I divide by everything but y prime. The negatives cancel, the sine y's cancel. And I do the same to the other side. Divide this by negative sine y. Now, if you have A divided by B and you divide it by C, I claim that you're dividing A by BC. A quick way of seeing this is just multiply by 1. Multiply the numerator by B and the denominator by B. A over B times B, the B's cancel, you get A. The bottom, C times B. We started off with A over B over C, and the B and the C get multiplied. That is, these two denominators get multiplied. The 1 stays on the top, the 2 square root of x sine y goes in the bottom. This numerator is positive, this denominator is negative. Positive divided by negative is negative. And this is equal to y prime. Okay. Now, I just need to get rid of sine of y. And that's where this triangle stuff comes into play. Somewhere we have the sine or the cosine or the tangent or what have you of an angle. Not the sine inverse or the cosine inverse. And that's right here. We know the cosine of y is square root of x. The cosine is adjacent over hypotenuse. Square root of x is the same as square root of x over 1. So we have square root of x over 1. The other leg is this squared minus that squared, which is just x. And the sine of y is done. The sine of y is opposite angle y divided by the hypotenuse, which is 1. The rule for dividing by 1 is don't bother. So instead of sine of y, I'm going to put the square root of 1 minus x. It's negative 1 over 2 square root of x times sine of y, which is the square root of 1 minus x. And there is your answer. Let's try another one. You need to be able to say their steps. You need to be able to do their steps. But even if you know how, even if somebody asks you to do these steps and you know how to do it, that doesn't mean anything because you need to know the steps. Knowing how to do the steps is good, but if you don't know to do the steps, there's no reason to do it. F of x is cosine inverse 1 over x. Just remember that that's y. F of x and y, same. They're equal. Same meaning, different notation. Now, we want to interchange these. 1 over x is cosine of y. 1 over x is x to the negative 1. I bring it up, it becomes, the exponent becomes negative 1. The 1, this 1 stays. For 1 times anything is to anything. The derivative, bring down the power. make the new power 1 less. The negative 1 has a positive exponent. It's 1. The x has a negative exponent. I cross the division line and I make the power positive. The derivative of 1 over x is negative 1 over x squared. The derivative of cosine of any angle is negative the sine of the angle times the derivative of the angle. The first thing I would do here is to change both signs. That way there's no negatives. If somebody tells me that negative x, for example, is negative 34, I see students suffer with this. You can change both signs. Even if you have negative x is positive 34, you can change this to positive. You can change the understood positive to negative. That's called multiplying by negative 1. All right, so now we divide the left side by sine y, and we just learned that make that the right side. And when you divide the left side by sine y, it goes with the x squared. Oh, this didn't come up. I'm sorry. Okay, so now we're kind of done. Y prime, the right side, is equal to 1 over x squared times sine y, or sine y times x squared. So that's where we come to the triangle part of these steps. We know what the cosine of y is. The angle is y. You really, really need to know you take cosine of angles. So if you're taking cosine of y, y is the angle. And it equals to, well, remember, cosine is this over that. Equals to 1 over x. So what goes on the other leg? That squared minus 1 squared, or 1. So now I can say what the sine of y is. It's the opposite divided by the hypotenuse. So instead of dividing by sine y, instead of taking 1 over x squared and dividing by sine y, I can take 1 over x squared and multiply by the reciprocal of sine y. Can multiply by the reciprocal of sine y, which is x over the square root of x squared minus 1. 1x on top kills off one of the two x's in the bottom, leaving 1x in the bottom. So what survived is the 1 on the top, the x times the square root of x squared minus 1 in the denominator. And that's exactly what y prime equals. Okay, let's try a couple more. Do lots of these, they become familiar. And rather than knowing rules for the derivative of sine of u, we just have to still just use the derivative of all the trig functions we know. We don't have to know any new rules. If you're given that y is equal to the secant inverse of 3x, well, interchange these two. 3x is equal to secant y. Since I interchanged the two arguments, the inverse disappears. Now I take the derivative of both sides. The derivative of 3x is 3. The derivative of secant of any angle is secant of the angle times the tangent of the angle times, which I'll put in front, the derivative of the angle. The derivative of y is y prime. It's always been that way. When you had y equals 7x squared, and you were asked to find the derivative, well, you would write down y prime equals 14x. And There's two reasons why you did that, because the derivative of 7x is the derivative of 7x squared is 14x, and the derivative of y is y prime. A lot of students don't seem to know that. The derivative of y, if we're taking the derivative with respect to x, the derivative of y is dy dx or y prime. Okay, so we divide both sides by secant y times tan y. Secant y, tan y. When it comes to the right-hand side, all we have is y prime. And that's why we divided by what we did. We just wanted y prime. And it equals to the left side. 3 divided by secant y times tangent y. So we need to find out, we need to get a triangle with an angle y, and there are at least 2 or maybe in this case 3 sides. And it comes from here. That talks about the angle y. Tells me the secant of y is 3x over 1. Secant is hypotenuse divided by adjacent. The third side should just be very, very routine, as long as it's one of the legs. It's this squared, 3 squared times x squared minus 1 squared. Okay, so now I can figure out what the secant of y is. In fact, we actually know that one. It's 3x. We know the secant of y. Times, you could have said it's hypotenuse over adjacent. 3x over 1 is 3x. Now times in the bottom by the tangent of y. Well, the tangent of y is opposite over adjacent. Adjacent is 1. Opposite over 1 is just the opposite. It's just the square root of 9x squared minus 1. And if you're in my class, I would definitely take a point off if you didn't do the division. 3 over 3 is 1. So it's 1 over x times the square root of 9x squared minus 1. That's what y prime equals. Let's look at the next one. I like this problem that I'm about to write down. It's time to have a little fun. Suppose you were given that y, or f of x, is the sine inverse of x plus the cosine inverse of x. And you're asked to find the derivative. Well, you could, for example, call this y1 plus and call this y2. So y equals y1 plus y2, then the derivative of y will be the derivative of y1 plus the derivative of y2. So that's what I'm waiting for. That's what I'm going to work on. What's the derivative of y1? What's the derivative of y2? Well, y1 is sine inverse of x. So switching the two arguments, x equals sine of y1. The derivative of the left side is 1. The derivative of sine of any angle is the cosine of the angle times the derivative of the angle. Dividing both sides by cosine of y1, we now have what y prime equals. But of course, we want to write it in terms of x, not y's. Okay, so this gives me a little triangle. It tells me that the sine of y1 is x over 1. It's opposite of y1 divided by the hypotenuse. So this angle is this squared minus that squared. So we get 1 over the cosine of y1. The cosine of y1 is adjacent divided by hypotenuse, which is 1. That is, you just get the adjacent. So right now, we have what y prime equals, y1 prime equals. Let us now go, let me erase this triangle, because I need the space, and let me find out what y sub 2 prime is. We're claiming, if you look at the top, that y sub 2, I'm talking about right here, y sub 2 we say is cosine inverse of x. Well, interchanging the two arguments gives us that x is cosine of y2. The derivative of x is 1. The derivative of cosine of y2 is negative the sine of the same angle times the derivative of the angle. So now I divide by negative sine y2. Negative 1 over sine y2. Put the negative on top. This is y prime. I just need to write it without y sub 2. And this triangle, or this equation right here will do it, because it generates a triangle where the angle is y2. The cosine of the angle is x over 1. Adjacent over hypotenuse. The other leg is this squared minus that squared. So we get negative 1 over the sine of y2 is opposite divided by hypotenuse. Dividing by 1 doesn't do anything. It's just the opposite that we get. Okay, so continuing right above this bottom line, y prime is equal to y1 prime, which is 1 over the square root of 1 minus x squared plus y2 prime. Oh, look at that. It's the inverse. It's the negative. It's negative 1 over square root of 1 minus x squared. Well, this sum, wish I just had just a little bit more space, but oh well. Maybe I can come up with it. This sum is 0. Okay, and that's the answer. But now, why did I say this was interesting? Well, if the derivative of this is 0, it must be a constant. It must be a constant. And if you caught that earlier on, you wouldn't have had to do any of this. That's a constant. I'm hoping that many of you are saying, yeah, that's pi over 2. 90 degrees, it's pi over 2. Do you get that? Well, you have to think a little bit. You have to think. If I call this, say, y1, this is still y1. The sine of y1 is x. It's x over 1. If I call this y2, then the cosine of y2 is also x. Well, you know what? If I put y2 here, that's the adjacent. And that's always the hypotenuse. The cosine of y2 is x over 1. That is y1 plus y2. Remember, the three angles in this triangle have to add up to 180. And if this one used up 90, the other two must use up the other 90, or pi over 2. Okay, this is what y equals. Remember, I call that sine inverse x plus cosine inverse x. y is pi over 2. This y on top is pi over 2. So, and pi over 2 is a constant. So its derivative is 0. The sine inverse of x plus the cosine inverse of x is pi over 2. Okay, let us do one more problem. This one will use techniques that we learned earlier on as well, back in Calc 1. Y is equal to x tan inverse is 3x plus ln of 1 plus 3x to the 4th. Suppose we want the derivative of this. Well, it has two terms, so it's going to be the derivative of that plus the derivative of this. Well, the first term is a product, so we can use the product rule. The derivative of the first, we know it's just 1. And at some point in the product rule, we need to take the derivative of the second. So why don't we have that on the side? This is a different y. Y is equal to the tan inverse of 3x. So 3x is equal to the tangent of y. The derivative of the left side is 3. The derivative of tangent of any angle is secant squared of the angle times the derivative of the angle. And divide the right side by secant squared. But you can always divide the right side by secant squared. And I want to divide the left side by secant squared. But whatever you put here, you can always multiply it by the reciprocal. The reciprocal of secant is cosine. The right side is going to be 3 cosine squared y. Now, all I need to do is get rid of the y. And I know from the bottom left equation on the board that 3x is tangent of y. Here's my angle y. The tangent is this over that. It's 3x. You can always divide by 1. It's 3x over 1. So what goes on the hypotenuse? You get this squared, not 3 squared, x squared, plus this squared, square root. On the hypotenuse, you don't subtract anything squared. It's always adding. Okay, so what's cosine? The cosine of y is adjacent over hypotenuse. And if I square it, I get 1 squared, which of course is 1, divided by this squared, which is 1. And if you were to multiply by 3, you get 3 over 9x squared. Something's bothering me. 9x squared plus 1. When you square this, you don't get 9x squared. You get 9x squared plus 1. So y prime is 3 over 9x squared plus 1. Okay, so now we have the derivative of tan inverse of 3x. Now we have the derivative. All right, so y prime is the derivative of this first, and then we'll add on the derivative of that. Well, this is a product. It's x times the tan inverse. So I use the product rule. The derivative of x, derivative of the first term, times the second term, plus the first term, which is x, times the derivative of the second term. The derivative of tan inverse of x, we just worked out. It is 3 over 9x squared plus 1. And that completes the product rule. We took the derivative of the first term. Plus, we have to take the derivative of the second term. The derivative of ln of anything. No big deal. Put the anything in the bottom and the derivative of the anything on top. The derivative of 1 is 0 plus the derivative of this. Bring down the 4, you get 12. Make the new power 1 less. Other than cleaning it up a little bit, we're done. The calculus is done. 1 times that, of course, is that, plus x times 3 is 3x over 9x squared plus 1, plus the last term. Okay. This completes the section on taking derivatives of trig inverse functions. In my opinion, and it's just my opinion, don't bother to memorize new rules.